Hello everyone, the purpose of this video is to provide an introduction to space mechanics and to help you understand easily what I'm going to teach you at synchronously teaching on Tuesday. Watching this video is not necessary for the Tuesday session, but I suggest you to watch it until the end because it will definitely help you to understand the Tuesday session more easily. By the end of this session you will figure out the orbital type of each spacecraft. We can write down the velocity equation for each orbit. Also you can model how the spacecraft behave in each orbit section, and I hope you can solve and calculate a simple related problem. At first, let's introduce you to some basic formulas. First, angular momentum, which is h, and we calculate it by the product of radius with velocity. And we know from the Kepler rules that the angular momentum is constant for every orbit. Radius is equal to this formula, and in this formula, h is angular momentum. Mu is the constant gravity coefficient, and E is the eccentricity, which shows the shape of the orbit. And as you can see, it's 0 for the circular orbit, and it's between the 0 and 1 for the elliptical orbit. And theta is the angle between the radius and the predefined coordinate system. Also, you can find out the formulas for the vertical and radial velocity for each spacecraft. Generally speaking, there is 4 types of orbital motion for a spacecraft in space, and in this video we're going to focus on 2 basic motions, circular and elliptical. In the circular orbit, the spacecraft travels at the constant radius from the Earth, and it has a constant perpendicular velocity. As it's obvious from the shape of circle, since the radius is not changed during the mission, the radial velocity is 0 in circular orbits. The angular momentum for the circular orbit is easily calculated since the radius is always perpendicular to the velocity, and since the angular momentum is constant number and radius is constant in the circular orbit, the velocity of rotating spacecraft in the circular orbit is constant, and it's equal to square root of mu divided by r. It's obvious that the circular orbit with the higher radius has a smaller velocity. Okay, let's go to the elliptical orbit, which is a little more complicated. There is 2 critical points in the elliptical orbit, and they are apogee and perigee. Perigee is the closest point of the orbit to the Earth, and the apogee is the farthest point from the Earth. In these 2 points, the radial velocity is changing to 0, and the spacecraft only has the vertical velocity. Also, you can find the eccentricity by using the perigee and apogee radius. To wrap it up, the elliptical orbits, by having the radius of perigee and apogee for each orbit, you can find all the necessary information you have needed to solve the elliptical orbit problems. I hope you learn and enjoy the basic information about the orbital mechanics. In the Tuesday session, I will teach some orbital maneuvers and try to solve a simple problem for you. Thank you and be safe.